we talked yesterday on our lovely walk that I did get yelled at, by the way. Remember when I said 7th graders are going to yell at me because we walked fast? And later they showed up. They're like, hey, you took Math 2 on a walk again.
How did they know that we were Math 2?
Because they know that you guys are the 8th graders that I teach, and they yelled at me for not taking them on a walk, and I told them that I'm not worried about you guys because you're going to finish your textbook, and then they got all offended, and it was a whole thing. But I did appreciate that we did some math while we were on the walk. So grab graph paper, because some of this we're going to need to write down and actually solve a few things, especially once we start trying to take standard form back to graphing form. So if we have this center, this circle, centered, at the origin. We talked yesterday about what the equation is going to turn into. X squared plus y squared equals radius squared. So here, we know that if this radius is out to there or out to there, we know that any of the radii are how long? Any of these radii, whether I go straight up the x-axis, straight up the y-axis, or out diagonally, all of the radii are equal, and they are how big here? 10, right? So if our radius is 10 here, I can replace this and say, well, this is really x squared plus y squared equals 100. And then, if we are told, okay, this x distance is 6. So it is a Pythagorean triple that is double the size of a 3, 4, 5, right, is what you're relating in your head, how you're jumping straight from 6 to get to 8. Because if we had 10 and we have 6, we see this is double 3, this is double 5, so this will be double 4 and it'll be 8. Is that the only y value when x is 6? It can also be negative 8, which reminds us that circles are not functions. This is not negative 6.
Oh, yeah.
Right? This is still positive 6. So then there are other points that would be negative 6, negative 8, and negative 6, positive 8. And all of those points we know would be true and on the circle because they would make that right triangle. What is up? I'm trying to wait and just kind of chill, but I'm confused at what's happening. Okay. I think Connor actually maybe already did that. I just grabbed the bin and shoved it in my folder, and then I did not get to grading last night.
I'm almost out of graph paper.
Good thing I got extra. And if you want another notebook, I got notebooks too that kids don't like to take because they like single sheets every day, but I like a notebook better. All right. Well, fine. That felt too easy for you guys. What about if...
I never said it.
Well, it felt like it did feel easy. What if x is 3 then? With this same circle, is that as easy?
No.
What?
No. Not 9.
If x is 3?
If the x value that we have gone out to is 3.
Oh.
But same circle. Same radius, same center.
Rad 91.
Hmm?
Rad 91.
Radical 91. Is that a nice number? Can I take the radical of that?
I don't think so.
So we're saying y would then be square root 91. Does that make sense how Jake got his answer? Because x squared plus y squared has to equal our radius squared. Before we get too far into the lesson, and I forget to do this, let's all write down the problems we're going to actually do. So your homework for 10.1.1, 10.1.2, and 10.1.3 Now, if you want a couple extra really good practice problems, 22 and 25 are also good problems. But I didn't want to, like, overload you guys. And for 10-1-3, like, we should cover 10-1-1 and 10-1-2 today. We'll probably cover the entirety of both lessons. We'll pick up anything from 10-1-2 we need to tomorrow. But we'll cover 10-1-3.
Is 10-1-3 a 2-day thing?
They plan it as 2 days because it's the, like, mathematical definition of a parabola and how we make a parabola. I don't think we will actually need 2 days for it.
So wait, how many lessons are in chapter 10?
I forget if we actually talked about my goal here, but to answer that question, here is my goal. So here's my plan book, right? 10-1-3, they budget 2 days for. So if we can move it to, if we cover 10-1-1 and 10-1-2 here, and then finish 10-1-3, these all bump up a day essentially. So imagine we're doing 10-2-2 by Friday, like I have written up here. What that allows us to do is shift all these up a day, put the closure right here, and start your test while I'm out for this day. I have to be out next Friday. If not, and this is what I have written in my notebook, you guys will just be doing closure while I'm gone. Mr. Lipel will be your,
Is that the teacher that came before?
yeah, the other, like, tall dude that kind of looks similar to me because we're close in age. Like, I mean, not like that we look the same, but, like, you know, same general, oh, it's like a white dude in his 30s. Like, I mean, come on, it's like, we look similar in that
Will
sense.
we work together on the test, or is it like you don't care?
I've not finished writing the test, so as long as you guys can, like, promise me that you'll be cool for Mr. Lipel and not, like, you know, make him do any, like, student management type stuff, I don't really care that much if you guys work together. Biggest thing I want to make sure is that you guys are comfortable heading into the state test. Not that I care about the state test, but I don't want you to be uncomfortable. So I just want us to all be comfortable. Would -8, -6 be a point on our circle? We did -6, like -6, -8,
Yeah.
but would -8, -6?
Yes, because they're both square.
So it's the other way to draw
Oh,
the 6, 8, 10,
right.
right? So instead of going 6, 8, 10, it'd be 8, 6, 10. Ah. All right, so moving on. If we have a circle centered at the origin, but the radius is 4, what would that equation be?
It'll be,
There we go. X squared plus y squared equals 16. If you're given this equation, what do we know about the circle?
The radius is
And
what?
you're right, the radius is 6,
The origin
and
is at 0, 0.
the center is at the origin,
Yeah.
or at 0. I knew what you meant, but yes. Practicing math vocab, because the test is coming up. What do you know about the circle in D?
one of
Is it
the
just a point?
X or
It's a
Y
point.
is
I'm
high.
so right.
It's just a point. Right? Yeah, like I think it was like right on the tip of your tongue. You're like, I think I'm gonna say it. It's a point, right? This is literally the graph of how you make the point at the origin, because you have a radius of 0, and then we have to argue, can a circle have a radius of 0, and it's a whole thing. So now we have this circle that's been shifted off the origin, which we talked about yesterday. I kind of let the cat out of the bag for most of these things. Shouldn't put cats in bags, though. That's mean. So how do we write the equation to fix... So I forget how far we made it in this conversation, but what we're doing with the, like, x minus and y minus is we're fixing the circle. We're fixing the math to make it work correctly.
Okay, so for that one it would be.
I called him.
Oh, hi.
I knew you'd be back soon.
That was your.
I don't want my pass.
That was Jake. It fell over right on top of him. It was actually pretty dramatic.
Are you good? I'm fine.
He caught it with his head.
Was I in the bathroom? That's so sad.
What?
That's so
Oh,
sad. Oh my goodness.
Man, like, building of Jenga blocks crushed my friend and I missed it.
Who was sitting with his friend?
Whoa!
I'm just a
All right,
his
Connor,
kid.
graph paper,
No,
please.
the associate.
Okay, yeah.
We found Shia.
Your associate, your colleague, if you
Yeah.
will, someone you work with.
Yeah. What did my
All right, so Connor, we're just now getting to the point of at the end of our conversation yesterday,
So it'd
really.
be x minus 3.
So we're gonna say this equation is x minus 3 because that would fix the math for the x.
Squared and then plus y minus 1
Minus
squared
1 will fix it.
equals 25.
Equals that radius squared of 25. Go ahead and grab a pencil if you need. Okay. So then it asked us what's the length of PB?
What do you mean what's the length?
Peanut butter.
PB, okay.
Yeah, peanut butter. So what do you guys think? PB is the length of the Y change. Yeah, I'll agree with you there.
It's 4.
How do you know? We can't just say, oh, it must
3, 4,
be.
5 times.
Do we know? But I feel like there's like an assumption. I don't know. But I feel like there might be an assumption being made.
I'm not going to say you're not assuming. It looks like a 3, 4, 5 triangle.
I mean,
It tastes like a 3, 4, 5.
It tastes like.
It looks like.
okay.
So remember, 3, 4, 5 is like a very particular. So all because we see that PA is 5, does that mean that this is a 3, 4, 5?
No.
Yes. Because it's a right triangle.
Here,
Show me another right triangle that doesn't have a 3-foot axis. That'd be very easy. But it looks like it, you know?
So how can we?
How did we get point B? I'm confused. We just put it there? We're just like, here you go. Sunny June. Sunny June?
So they give us
Oh,
point.
because we have the hypotenuse.
They give us point P is XY. So what we're being asked is how long is this?
Well, we know it's 1 off the top, so we just need to know how tall it is.
Wait, we know what?
It's 1 off. It's 1 up. It's like. So we just need to know, like, how far the rest of that is.
We know that that gap is 1. So if, big if we know this Y value,
plug it into the equation.
Well, you just subtract 1 from it and then you get the.
so if we know this Y value, the length of PB is that Y minus 1 because we're 1 up from the axis. Otherwise, if we find that point, we are the length of that point, but we got to take away the 1 because of here. So similarly, what about the length of AB?
Wait, but B could be like anywhere. Like it could move like left and right.
Can B be at a different location than this Y? Or sorry, than this X? Like, would it not be in a straight line?
It wouldn't go up and it wouldn't make a right angle if B was in a different spot. But like
So therefore,
P and I don't get how we know where P is. Like where did the X and the Y go?
because P is on the circle. That's all we know. We don't actually know exactly where P is right now, but P is
so
on
it
the
could
circle.
actually be like really squeezed like this, or it could be really open like okay.
But what we know is the radius is 5, and this is the equation that matches the circle when the center is at 3, 1. So are we good on knowing how we got the equation? Are we good on knowing that P is on the circle? So then, this length is whatever this Y value is, take away 1 because we're 1 off the bottom. Similarly, the length of AB.
Whoa.
I don't like this. I don't like this. I don't understand it, and I don't like it.
Imagine we grab the circle and move it so the center, A, is here. Effectively, what we're doing when we go to do the math of the lengths or any of the the circle math we're doing is we're fixing it, right? We're saying, oh, well, we would just be length Y, but we're 1 off, so let's take 1 away. We would just be length X, but we're 3 away from the, so take 3 away.
So really, this is showing how you're taking that outside point, and as long as it's a right triangle that matches the things, that 1 point
And this goes back to what we talked about when I kind of over-taught with the unit circle and sine and cosine, is that these all relate together, sine, cosine, and tangent, all together in this right triangle math, which then makes the circle, because if it's all doing the same thing, it creates a bunch of points all in a circle. So let's practice this to actually get this into our heads in a good way. Let's try this. Let's try these. Two different equations for these two different circles. Write the equation. Sorry, I guess I scrolled too far. Write the equation for each circle.
X minus 2 squared plus y minus 7 squared equals 1 squared.
That's an interesting equation. Just equals 1. X minus 2 quantity squared y minus 7 quantity squared equals 1.
Would it be x plus 5?
Oh, the middle. Wait.
It's just x squared plus y squared equals 25.
Yeah.
Yeah.
No, wait.
Yeah.
Yeah.
Because it's 0, so it's on the axis.
What is 0?
The middle is the origin. The center of the circle.
It's on the x-axis.
That's on the y-axis. 0, 0.
Yeah, I feel like this picture doesn't match what they say.
Yeah, that's because it's 1, 3, 2, and 4. They're 4 different things.
2 and 4 are their own problems.
Yeah, the picture they do.
There you go.
Oh, that
it-
took a while.
In the
My
previous
God.
year, kids were like, this doesn't match. And I was like, but wait, it's very close to looking like it matches, right? So if I draw my diameter here, it might be at -5, but it's definitely not at +5, right? So if this, I'm not using that. If this tells us -5, +5 for the diameter, well, that means we're centered on the y-axis, and then the x's, if we center those, so this is just x squared, just y squared, 25. Ooh, yeah, 25. Because diameter then would be 10, so radius is 5. What about 2?
Well, the radius for it is 2.
The radius is 2.
The radius is 2. So it equals 4.
X.
So it equals 4.
X minus 3 and then
Y.
squared and then y minus y minus. Wait, y minus 5, right?
What?
No.
It's the
The
center.
question is, where is this
We're
point?
looking for the center.
Oh, right. So it's y minus.
What about here?
That would.
Careful.
It's x plus 2.
Ooh.
Y minus
X plus, because it's the opposite,
Yeah.
right?
Equals 16.
Crap.
And then.
No, equals 9.
Yeah, x plus 2 squared.
Careful that you include the plus here, because we've been so used to writing binomial times binomial.
X minus.
No, y minus.
Oh, yeah, y minus.
1.
Equals 16.
Good catch.
Right? Well, no.
That equals 9. I thought it was 16.
Questions? Alright, let's keep
What
rolling.
do we do when it's not? Well, I guess it's not like it would be harder if it was not. Well, it would be harder, but it's not like we change it to the same as we have to.
So,
Not a nice number.
how would we sketch?
Well, the first one is linear, so
We
that's
get out of
First
the-
one's linear.
So that's a function.
And then,
The
second one,
is
We put
it's
it
like a circle.
we put the center at -2, -3,
-30.
with a radius of 3 units.
No, they do not both describe functions because circles are not functions.
so then, if we have to solve for where these these two different equations meet,
Probably at about 2 points or 0 points, or 1 point.
you are correct. Those are our options. 0 points, 1 point, or 2 points.
But it's very likely that it's 1 point unless it's a tangent line.
Yeah.
How So it says using an algebraic method. Thank you for the advice, CPM.
Do algebra.
What is do algebra? What can we do here?
We can
You guys
isolate-
seem to not want to draw it.
We can isolate y and then set the equations equal to each other.
Yeah.
Okay. I don't even know how to isolate y right now because everything has squared and a bunch of stuff
You could
happening.
square root
You could add 7 to both sides.
Square root everything.
To the right side. Wait, that doesn't.
Okay, we could square root everything to start.
Makes it a bit easier to handle.
So could I rewrite this as x plus 2 plus y plus 3 equals 3?
No.
Because then it
You
will
need
be
to
like
keep
one
the
solution.
squares.
Because then it will only have like a couple solutions.
I don't have one.
Well, by square root 9, I guess this would need to be positive or negative 3.
Yeah.
But is that, so if I change that to positive or negative 3, is that correct?
Well, all of them have to be positive or negative by that
Yeah.
logic. Positive or negative, well, the y.
What
It
else?
doesn't quite
Wait,
work.
what? There's like 3. You could do
Positive or
that.
negative, the absolute value of y.
Could we?
We could. What's the subtraction method where you like add them together and that won't work? But if you square.
Oh, substitution.
Yes.
Oh my God! I forgot that's
Yeah.
a thing.
I just figured it out.
So substitution would reduce us down to a single variable. Try that. Substitute and be careful with your math. Connor, would you do me a favor and actually write this one down? Well, that wasn't an answer to my question of would you do me a favor and actually write this down. So now we get to practice our squaring binomials again.
Okay, I probably got this wrong.
Well, there is another option involving substitution. Jake's like, stop it. So, Connor, if you want to try something different, one thing I notice is this is actually this.
Oh, so you can substitute that in. Oh, that'd be so much easier.
You could replace y in for the x plus 2.
Then that's just 2y squared
I got.
plus 9
Wait.
equals 9.
So try it that way then.
So
If they're
y
they're going the first way, you try this way.
Wait. Jake, what did you get?
And we'll tell you there are 2 intersection points.
Oh no.
Oh no.
Wait, there are?
Wait, substitution. Does that mean I put that?
Remember, when we square root, we get 2 answers.
Wait, what happens if
Oh, I must have done something wrong.
I also must have done something. 3 points. How'd you get?
Your answers end up being integers.
Okay.
Oh,
Is
well,
this
I
one
definitely
intersection?
did.
I think,
Well, what do you have?
-5, -2.
Negative 5 is correct.
-2 is not.
You're saying negative 2, right?
Yeah. No, wait, no. I know what it is. Okay. Wait. Am I doing this one?
All right, I'll follow you guys on method 1 that we said before I showed Connor the easier method 2.
Oh, I forgot that you had to.
Well,
I
we could
forgot how.
substitute x plus 2 with y if we wanted to. But, so if I don't do that, I get x squared plus 4x plus 4 plus
X squared plus 10
Or if I subtract 9, I can turn this into a quadratic.
That's true.
So I subtract 9, I could do 2x squared plus 14x
plus 20.
20.
And then you can divide the whole thing by 2.
We factor out a 2.
And then, okay, wait. 2x squared plus 7x plus 10x. And then you can do 2 times the quantity of x plus 5 times the quantity of x plus 2.
I feel like I just
This is route 1 that we said substitute the x plus 2 in for the y. So then x is negative 5 and negative 2.
Which is what I said.
Well, so if we plug that back into our original like circle equation.
Yeah, we have to
Interruption.
plug it in.
Guinevere, Ronches, Gersh, please come to the office. Guinevere, please come to the office.
Sure, if we plug these into the equation that we're working, it should make 0. It should make what we set up. So that's not what we want. We want it to give us the value of the other variable.
Yeah.
Well, wait. If this is the intersection of both lines, do I have to plug this into the circle?
no.
I can plug it into the line.
Oh, yeah.
Right? Because the intersection point makes it true for both equations.
Is it 2, 4, 5, 7?
It is not, as we've been working through right here, talking about how to get to the solution, but I think you've been in your trance.
Wait, so.
So, hold on. Jake, are you taking the way where we substituted in the x plus 2?
No.
Are you
Yes.
taking the way where, what?
Yes.
Yes? So what we should have gotten is x squared plus 4x plus 4
Yeah.
plus x squared plus 10x plus 25
Yes.
equals 9.
Yeah.
Then, put things together, combine like terms, subtract 9 on both sides to make it quadratic.
Oh,
You gonna do that?
I didn't do that. No,
Then you went a more difficult route.
I just kept it as 9, then I got 2x squared plus 14x plus 98 equals 70.
98.
You went a bad route and started making some mistakes.
I tried completing the square.
We're not there yet.
Yeah. Oh, no.
What? Of course, complete the square is useful, like depending on the situation. You shouldn't groan when we talk about like that's a I don't want to say trick. That's like a strategy to make things easier, right? So this is what we did when we made it quadratic. Then we factored out a 2. And then we found that 5 and 2 work to make 7 and 10. So then we get x equals negative 5, x equals negative 2. What we were just saying is since this makes it true for both equations, I can't tell if you're still listening or not. Because when you shift your focus, I can't tell if you're going back in your zone of like the rest of the world doesn't exist. I can plug it into the line. So if x equals negative 5, what does y equal?
Negative
And if x equals negative 2, y equals 0. All right,
So those-
let's go the other route.
Oh.
The route that I suggested to Connor might be a little bit easier, but I don't know. I mean,
I just didn't make the x's negative for some reason. I must have messed up. Because I got 2 and 5, but I didn't get negative 2, negative 5.
so if instead I plug y in here, because I realize x plus 2 is right here, we can do y squared plus.
Wait, what did you do?
So I look at these, like actually take a moment to pause and look at what we've been given.
Yeah,
X plus 2 is y,
Yeah.
is what they're telling me. Okay, x
So
plus
that's
2
y. Oh.
is y.
Okay.
So replace that with y, making this y squared.
That does seem a bit easier.
Then this will become y squared plus 6y plus 9.
Oh, wait, that is easier.
That's
It's 2y squared plus 6y equals 0. Which is so.
If we subtract 9 from both sides, yeah.
X equals 3.
This is going to be y equals.
Oh, wait. Y plus 3. No, what? Am I right?
I don't know what you're trying to tell me to do.
I don't
You've mumbled a few
wait,
things.
No.
See, divide by 2 and then you get y squared plus 3y plus 0.
Yeah,
Oh, I
okay,
didn't
that's
do
what
it
that's
that
what I
way.
said. Yeah.
That's probably why I got different answers.
3, and then you get a 0 and a 3.
0 product property,
Wow!
but it's not 0 and 3.
Oh, 0 negative 3.
0 and negative 3.
That is so much easier.
Well, it depends on your brain. There's always multiple ways. Almost always multiple ways. You choose whatever you think is the easiest. Questions?
Yeah, I did it wrong.
Well, that's not a question, that's a statement.
Well, I want to know why the way I did it didn't work.
Do you have it written down?
Did you
Yeah.
break the pencil?
So
or did
if you
take
go
it
back
out?
to 2y squared plus 6y, I know this is like.
So you're saying go back, like back.
Go back to take that, and then subtract 6y. No, that
No,
was.
go,
no,
Oh.
Tell Mr. Hudson to stop.
Okay, there. Go back one. Oh, go back one more. Okay, subtract 6y from both sides,
Okay.
and then divide by 2.
Why did you do
I felt like it. And then y squared equals
squared.
negative 3y.
Oh, I dropped the squared, sorry.
And then I did so.
So what number
And
squared?
then I factored out y from both sides, which means y. Like, because y squared is y times y.
Oh,
So I divide both sides by y.
So wasn't that one of our
It
y's?
should be plus or minus. But, like, yeah, but. Oh, and if it was 0, it would also work.
If it was 0, this
Yeah.
statement also works.
But what about if it was positive? No, because that's. Oh, okay.
We good?
Yeah.
Everyone feeling all right?
Yep, we're good.
Well, no, not feeling alright, but yeah, I
Well,
understand that.
Oh.
So jumping into 10.1.2 a tiny bit. Sorry, this goes over some 3D like stuff that we're not doing right now, but is going to come up. And like, there's a homework problem about this stuff, but I think I told you guys to skip it. Connor, I need to hand you a post-it with what our homework actually is. So, like, I think it was you that brought up to complete the square.
Look, he did it.
One of you said complete the square. It's like you read my mind of what's coming next. So, if we talk about this being our graphing form setup for a circle, remember H and K, we just started using H and K for horizontal and vertical. I don't know why K for vertical, but okay. So, we have,
Because v is already velocity.
yeah, we have this is what the standard form is going to look like, right? That's graphing form, whereas standard form has done the math, right? It's done the squaring and whatever, and it's added up the like terms. So, similarly, but kind of in reverse, if you're given this, what is that circle?
Wait,
If you're given this, how do we work it backwards to figure out what the circle
Sorry.
is?
does that say that x squared and y squared will always have the same coefficient?
That's what it looks like,
Okay.
that they always both have A. So here they both have a coefficient of 1. What do you think we should do first?
Well, it's
Subtract
x
11.
minus 2 and y minus 2. We should factor it
Oh
back.
yeah, that's another way.
We should put kind of like terms at least with each other. Not necessarily, or not like terms, right? But similar terms, I guess we can say.
It's x plus 2 and y
So
plus
x squared plus 4x plus probably something. And then y squared plus 2y plus probably something
Yeah.
1. It's 1 and
equals 11.
Yeah, it is.
Plus something if we start messing with stuff.
So it should be 4x plus 2.
Wait,
No,
how do you
it's-
get 1 and
Yeah, it's 4x plus 4, yeah.
So hold up. Let's talk through what we're doing because I feel like we're jumping over each other.
Like, when you go back to that equation that you have right there, those blank spaces, to make that like a square, it has to be 4x plus 4.
Oh, okay.
Which
That
we
makes
have-
sense.
How do we know that?
Because
Because
it's
half of
Because it's like completing a square.
half of
Yeah. Okay.
You because this would be a 2,
And that would have
because we know this is half of b.
that
If
makes
this
sense.
is squared, that becomes, now hold up, I'm going to change color there, because we're going to need to keep track of this. Guys, this is stuff you need to practice to know if you actually can do it without mistake. So then, y
Plus 1.
plus 1 squared, this is going to be,
That's 1.
Because one's
and what do we then also have to make sure we do?
Add
Add 5 over here. So this becomes x plus 2 squared plus y plus 1 squared
16.
equal
So then the
16.
center of the circle would be -2, -1, and the radius would be 4.
I totally didn't think 11 plus 5 was 15.
Questions on that?
How simple.
Good. Do it once really quickly before we go to lunch. So we have 1x squared, 1y squared, 4 x's, 2 y's. Wait,
This is the
isn't that what we just had?
Yes.
Yeah, that's because we don't need this. Do this. I'll write it out bigger so you can see it. But we're not going to lunch until we all solve
Can we
this
do it
on
on the
paper.
board?
On paper. Using a pencil, using our hands, using our brain. On paper. Now, I have a personal bias here that this is set up wrong.
Yeah, it should be set up like with similar terms.
Well, that and in the last one we did, was this constant on the side with all the other stuff? On the one we just did, they had the constant on the other side. So I really feel like the constant should be on its own. And then, like Akshay said, put the similar terms together. But for the sake of getting you guys out of here in time for lunch, let's start tomorrow's lesson with this problem.
No, I
So-
already got it.
I almost got it. Wait, is it plus 6? Yeah, 6, so then x plus 3.
Got it.
Yeah, I don't think I can jump right to the final step. I think
got it.
we need to write the in between.
2, -3.
The term is 2. Yep.
-4, yeah, that's what I got.
Well, it said rewriting graph. Oh, yeah, the sketch. Do we have to do the sketch graph?
No, please say
We'll do that stuff tomorrow.
Right.
Why don't I just draw it?
I don't like sketching circles.
So you said this is -2, making us add
add
4.
4,
4. This is +3,
making us add 9.
making us add 9. So we actually add 13 in total.
The -3. Oh, yeah.
I'm bad at drawing circles, but that's about what I got.
All right, there we go. Good work, guys. All right, so if you're not here tomorrow, I will try to make sure that we record the video and get that posted. Oh, Connor, you can.
Bye, thank you.
Thank you. Do you got a plan book or somewhere to write this? How do you keep track of what to do? You got a piece of graph paper to put this on?
It's in my big round. Actually, should I borrow some more graph paper?
Yeah, grab a sheet. There's your homework
Oh,
for the next 3